Okay, question 13. We're given the fact that the nth term of a sequence of triangular numbers is n plus 1 all divided by 2. Prove that the sum of any two consecutive triangular numbers is a square number. It doesn't actually matter in this question if you've forgotten or don't know what a triangular number is. Triangular numbers are these. They form a triangle. For example, if you put n is equal to 2, we should get the answer 3. 2 multiplied by 3 divided by 2 is indeed 3. So this formula does represent the number of white dots as we go up from n is equal to 1 to n is equal to 6. So in a way, that's a bit of side knowledge that you don't need. So what we've got to do is take this number and add it to the consecutive next number up in the triangular number sequence, and then prove it's a square number. Okay, let's have a go. So we've got to take this number first, and we add it to the next one up. So each of these n's go to n plus 1. So this is n plus 1. This will be n plus 1. Plus another 1, and that's divided by 2. So multiplying these brackets out, we get n squared plus n over 2 plus, this is n plus 2, so we can multiply that out, and we get n squared plus 1n plus another n, which will be 3n, and then 1 multiplied by 2 gives 2. And this is divided also by 2. Bringing this all together, it will all be divided by 2. So all I've done there is put everything over the common denominator of 2. Now we bring everything together. We've got 2n squared plus 4n plus 2, and that's divided by 2. We've got a common factor of 2 which we can take out, and this turns into n squared plus 2n plus 1. Now, is that a square number? Well, we've got to factorize it to find out, and it factorizes very easily to n plus 1 multiplied by n plus 1. And this is equal to n plus 1 squared, which is a square number. And we've proved what was required.